So we have talked about the law of sines quite a bit, and the law of sines doesn't always work. The law of sines does work for angle, angle, side. It does work for angle, side, angle. And side, 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 it doesn't work. Because for the law of sines, the law of sines includes two angles and two sides. So if you know two sides, you need to know an angle in order to find that other, in order to find the other angle sometimes. If you know two angles and one side, sometimes you can figure out that other side. For example, side, angle, side. Let me show you this. Side, angle, side would be like this side, this angle, and that side. But the trouble is, the law of sines, so for instance, sine of A over A, would be like this and this. And then sine of B over B would be this and that, and you can see that's not going to work. Because each one of those things that were given is not opposite something that's known. That is unknown, that is unknown, and that is unknown. So side angle side doesn't work either. Okay. The other one we've spent a lot of time on is angle side side, and that actually does work. Sometimes there are no triangles, sometimes there's one, and sometimes there's two. Okay. We're going to learn today something called the law of cosines. The law of cosines also works sometimes, and there are two cases where the law of cosines won't work. So if you're given a triangle with three pieces of information, you can find all of the other pieces using either the law of sines or the law of cosines. But you kind of need both. One won't do everything for you. The law of sines won't do these two, and the law of cosines won't do some of them also. So here's what the law of cosine is like. All right, you have this picture. This is just triangle ABC, and I've drawn what's called an altitude. This right here is an altitude. It touches one of the angles, and it's perpendicular to the opposite side. I've labeled the length of the altitude K. It's just a random variable. And then I've labeled this little side here X. I could have picked any number. So what I've basically done is cut this into two right triangles, a blue one and a green one. All right. Now, all of the sides in the green triangle are listed, and those in the blue are not. So I could call this Y, but what I'm about to do includes getting rid of all of the variables. So if I can avoid putting it as another unknown variable, I'm going to avoid that. Sorry. Okay, so instead of calling it Y, I'm going to use length B and length X. How long is the base of this blue triangle in terms of B and X? It seems close to X, right? But I actually don't know how long X is, and I may have drawn the triangle wrong, so don't let the appearance sway you. How would I calculate this distance? It looks half of B, but the triangle might actually look more like this. Oh, good. B minus X. That's what we want. Because we want this to represent all triangles, not just one where these two angles are equal. So we'll call this B minus X. Okay? So the Pythagorean theorem for the green triangle is going to be K squared plus, how would we do that? This one squared plus X squared. A is actually the hypotenuse. So X squared equals A squared. Everybody okay with that? Leg squared plus leg squared equals hypotenuse squared. Let's do the same thing for the blue triangle. So it's going to be K squared plus B minus X squared equals C squared. Okay? Well, What if we combine these two equations to eliminate the k squared? So what I'm going to do is subtract each of these from the one above it. K squared minus k squared, 0. So now I've gotten rid of k. What is x squared minus b minus x squared? Yeah, you can't actually do that, so we'll just write x squared minus b minus x squared equals a squared minus c squared. Okay. Now I need to try to get the x's alone. In fact, I want to try to eliminate the x's. So right here I have b minus x squared. I'm going to write this off to the side. B minus x times b minus x. What does that give me? B squared minus bx minus xb, but I might as well write it bx again, plus x squared. Can that simplify it all? Sorry, this shouldn't be there. These go together, right? So over, back to this equation, x squared. Now I'm going to subtract b squared minus 2bx plus x squared equals a squared minus c squared. Close that parenthesis. Wow. Okay. What does this negative do to those values inside the parentheses? Changes all their signs. So it's x squared minus b squared minus or plus 2bx minus x squared is a squared minus c squared. Does anything simplify? I can combine the x squareds to get 0. I have a positive x squared here and a negative x squared here. So I get rid of those. Now I'm left with 1x. I got rid of the k squareds. I got rid of the x squareds. Now I just have an x. But before I fix that, just because we typically write the equation in a specific way, I'm going to add this to the other side to make it positive, and I'm going to add this to the other side to make it positive. So c squared plus 2bx is a squared plus b squared. All right? I have one little trick left. I want to replace x with something that's equivalent that doesn't have an x in it. So if I go back and I look at the green triangle, now the red triangle, and I look at angle C, is there a trig ratio that uses x and a? Cosine. Now I could pick sine, which would use k and a, or I could pick tangent, which uses k and x, but I want to use cosine because I've already gotten rid of the k's and I don't want to use another k. So the cosine of c is equal to x over a. Can I get the x by itself here? What? It's a multiply problem, so times by a. So a cosine of c is x. So in my equation over here, I'm going to replace x with a cosine of c. Don't worry, we're just about done. Now, just because of the way we write the formula, I'm going to take all of this and move it to the other side as a negative. So the end formula is c squared equals a squared plus b squared minus 2ab cosine of c. Okay, we're done. We have the formula. We'll write the other two formulas in just a second, but this is basically all you need. Right? Does this formula look similar to something we use pretty much every day? What? It looks like the Pythagorean theorem, right? The only difference is this extra stuff on the end. Well, what is angle C when we use the Pythagorean theorem? What's the measure of C when we use the Pythagorean theorem? So, right, if I had A, B, and C, then this would be big C, big A, and big B. Angle C is always 90 degrees. Well, what is the cosine of 90? On the unit circle, at 90 degrees, we have 0, 1. Cosine is the x value. Cosine of 90 is 0. Well, what is negative 2 times A times B times 0? 0. So this right here says if C is a right angle, then all of this goes away, and you're left with the Pythagorean theorem. If not, you have to keep it, and this now works for every single triangle. So all of these years you've been studying the Pythagorean theorem. The Pythagorean theorem is just a very special case of the law of cosines. The law of cosines covers any angle from 0 to 180. If the angle is 90, then this piece drops off, and you're left with the Pythagorean theorem. Okay, now let's look at a couple things, a couple specifics in this. What do you notice about the formula? How much information is necessary to use the formula? So the law of sines uses 2 angles and 2 sides. What does the law of cosines use? Close. All 3 sides and 1 angle. Right? We have little a, little b, little c, and 1 angle. Okay? Now, could I change this formula to another form? If I were to put a squared here, what would it look like? C squared plus b squared minus 2 cb cosine of a. Good. Or the third version would be b squared equals a squared plus c squared minus 2ac times cosine of b. And all of those formulas are equivalent. It just depends on which angle you're dealing with. Okay? So going back here, the law of sines is 2 sides and 2 angles. Law of cosines has 3 sides and 1 angle. So if we look at the law of sines, why does SSS not work? Right, you have to have at least 1 angle. If you have 2 sides, then you need an angle. And this one does have 2 sides and an angle, but it's the wrong angle. That's why this one doesn't work. It has to be the correct, one of the 2 correct angles. Okay, so over here, law of cosines, will angle, angle, side work? No, because this has 2 angles and 1 side, and I'm only allowed to use one of those angles and one of the sides, so this one is a no. What about angle, side, angle? It won't work either for the same reason. Okay, what about side, side, side? If I know all 3 sides, can I find the 1 angle? Yes. So this one now works. What about side, angle, side? So I need, the equation has 3 sides and 1 angle. If I know an angle and 2 of the sides, then I can find the missing side. Yep. What about angle, side, side? Well, 2 of these and 1 of those only leaves 1 side, so this actually does work. But you have to be careful because you still have to worry about 0, 1, or 2 triangles. Okay? So basically, what this is saying is, if you're looking at a triangle with 3 pieces of information, if 2 of those pieces are angles, you're going to use law of sines. So the rule here is 2 angles. If you know 2 angles, then you can use the law of sines, as long as you have a side. Okay? The law of cosines, you need what? At least 2 sides. See, these both have 2 angles. These all, in fact, these all have 2 sides, but the one exception is the ambiguous case. It works both ways. Ambiguous. Ambiguous means not definite. So when my kids ask me a question like, can we play the Wii tonight? You don't tell them no, and you don't tell them yes. You say, maybe. That's an ambiguous answer. So an ambiguous triangle means they've given you information, and you're not sure, is it 1 triangle, is it 2, or is it 0? So that's parenting 101. Never tell them yes, and never tell them no. Just say maybe. Okay,